as I do from home every time I have a meeting. Are you hearing me? Do you hear well? Okay, cool. So, I'm Brujo Benavides. I am going to talk about test-driven development now, but first, a disclaimer. I live in Spain, so at this time, every day, I'm doing siesta. I have to speed up a little bit because time constraints, but if it gets too slow and I have to cut it short, you know what it is. Okay, test-driven development, right? I assume that most of you already know what it is. That's why you are here. But it won't be a good test-driven development talk if I don't explain what this thing actually is. It's a methodology, it's a way of working, and a way of writing code. I actually want to tell you how I learned that thing. So it all started when I was 10 years old. And the first test-driven development has 3 parts. Test-driven development, how creative. But the development part is the first one that I learned. I was 10 years old, I had a computer, QBasic, I wrote my code, and that was it. Test, what is a test, right? Who needs that thing? So I write the thing, I put it to run, and I check if it worked. If it crashed, I fixed it. Later on, much later on, when I started working, I learned about tests. Somebody showed me that that thing that I did, testing my code after every change, could be automated. It was a mind-blowing moment. And not only automated, it can be repeated afterwards. If I test 10 different things, I could just run one command and test all those all at once. And also, I can put it on some sort of platform, so it's run for everybody, not just for me. It's amazing. And I thought at that point that I had learned test-driven development. I wrote my code, I wrote my tests, they were automated, they ran everywhere, all the pull requests were checked. What else was around it? Well, the thing is that I didn't know about the driven part, which is the key part here. I was at the university. I had finished all the mandatory classes, and to get my degree, I needed a couple of extra points that you get by doing optional classes. There was a class about object-oriented programming, and I thought 2 free points. I've been doing object-oriented programming for a couple of years in C#.NET. What else would I need? I was very, very wrong. That teacher, Erlang, showed me Smalltalk. And Smalltalk, it's really different to other object-oriented programming languages. I will say something now. To me, it's the only one which does object-oriented programming correctly. All the others, kind of close, right, at some point. And I learned that only through that class. And Smalltalk is designed in a way that if you do test-driven development, if you apply this methodology correctly, it will help you and guide you. Because the methodology, the driven part, is this. You first write the test, and you write it knowing that it will fail. You make it fail, and then you fix the errors. And the Smalltalk virtual machine has an amazing thing, which is that when you run the test, when they fail, it automatically tells you and suggests to you what you need to do to fix them. It's super easy to work on that. We don't have that yet in Erlang, but we have a couple of things that are also very helpful, as I will show you today. So, from here, what I need you to understand is that this talk is not a talk about writing tests. It's a talk about writing code, guided by tests. But the end result is the code that you will get for your system. With that in mind, I divided the talk in multiple stages. Maybe not the right term, but I will start with a simple one, then a little bit more complex one, then a little bit more complex one, etc. The first one is what happens usually when you are learning Erlang. I am a trainer, so many times in my life, some of my students are here. Many times in my life, I taught Erlang to people, and I usually surprise them because one of the first things that I show them is how to write a test. And in general, when you learn a new language, people that teach the language starts with, this is a variable, this is a number, this is And I said, OK, we will get there. But first, this is how you write the test. And that's because Erlang makes it easier to do that. Let me show you with an example. And of course, if I am here, and this will be an example, you know where it's going, right? Emojis everywhere. If you don't know what I'm talking about, check Bmoji on the Spawnfest GitHub. If you don't know what Spawnfest is, check spawnfest.org and participate. You can get very, very good prices. It happens next week. Not to enter on a side tangent, what we are going to build is a very simple thing, an emojifier. It's something that you start. It gives you something that is the emojifier. And then you add translations from text to emojis. And when you run emojify, you give it a string, and you get the string with the emojis back. Fairly easy, right? But we are going to write it using test-driven development and not just jump in and write the functions. So the first thing we do is we create a module called emojifier. If you're missing the parentheses there, they are not needed. I like that thing much better. And but the module on its own does nothing. So the very first function that we add is the test. Because this is test-driven development, what we first need to write is the test. And the test has to say what our system is expected to do. The test function is a very simple function, no arguments, and returns a check mark, obviously an emoji, because everything emojis, but it can return OK or whatever you want. And now we have to write the test. The test is a list of assertions that say, when you start an emojifier, you get an emojifier. When you emojify a string, you get this other string, et cetera, et cetera. And Erlang is great for that because it has a matching operator, equals, that basically works as an assertion. Every line you write with an equal says what's on the right side. It's not equal, but it matches what's on the left side. And that's even better than an equal. I don't need to create something to compare it. It's like it has this shape. In our case, we start with the start function. The start function, as we saw before, has to return something, OK something, a tuple with OK and something. That's the only expected thing from start at this point. So if it does so, it's OK. So what do we do now? Anybody? What will you do now? Now you have this code. What's the next step? You run it. Very good. Excellent. You don't go and write the function because you know how the test will work. No, you go to the console, compile the module, run the test, and the test will tell you what you need to do. This is the part that we are missing. We get an error here. We don't get a suggestion of how to fix the error. But it's reasonably clear. It says the function start with no arguments is undefined in the module emojifier. So we go to the module, and we define the function. We define the function in a way that makes the test pass. On this one, it won't be that controversial, but you will see later that you can write the whole code as your mind thinks about the code. Don't do that. Write only the thing that makes the test pass. In this case, I'm strategically picking a map as a representation of the emojifier because I know that at some point I will have to have mapping from text to emoji, but you could return anything there. Then you go to the console, run the test, and the cycle repeats itself. Next step, more tests. So I decided to start with the emojify function, but you can start with the add function or whatever other functionality that you have in your code. But in this case, I'm adding two assertions. If you provide an empty string, the emojifier returns an empty string. If you provide some string, it returns the same string on the way back with no changes because there are no emojis defined yet. So let's see if that works. Of course, it doesn't. We need the emojify2 function. Same thing as before. We write the emojify2 function, and this is where it gets interesting. Because you will be tempted to write the emojify function, right? With everything that function needs. But the test doesn't say that. This is a valid emojify function for the test. And that's what you are expected to write if you do test-driven development. Something that makes the test pass. That's it. You will make it more complex when you write better tests, when you express your desired functionality better. So far, we only need something that returns the same second parameter. And that, of course, works. So let's add specifications for the missing functionality. It basically says, you add a mapping, smile with those columns on the sides, to the smiley emoji, and then it is replaced on the string that has it. And if the string doesn't have that thing is not replaced. So now the tests don't pass because we don't have the add function. So we add the add function. Once again, you will be tempted to put everything in that add function, but it doesn't need to. Just returning something that has the same format as the result from start, it's enough. And so we run the test and still doesn't work because we need to convert smile with the columns into the smiley emoji. And so we do that. This is, I am like moving a little bit faster here, but it's basically, the function basically does what the description of the test implies. We have a list of emojis already, so we traverse that list with the maps fold, and then we replace each one with the corresponding emoji. People, I see your faces. I see you saw the bug there. Wait, stay there, stay with me. So I go to the console, and before that bug, we have this thing. Hello, IO data, right? String replace doesn't return a string, but the test had a string as a return. At this stage, there are two possibilities. Either we think that IO data is valid return for the function, and so we fix the test, or we think that emojify function must return a flattened string. So that it fits in the screen, I thought I would make emojify return a flattened list to comply with the test. But the other way around is the same. You just need to put the list flattened on the test instead of on the code. We run the test, it works. And here we go again. What happens? If we have two emojis, that thing doesn't work. If we have a same emoji multiple times in the string, that thing doesn't work, etc., etc., etc. Let's fast forward. All those changes, step by step, trust me, you can do it one by one. In the end, it's something like this. You have a string with two different emojis. You have a string with 2 times the same emoji. You can have multiple other tests in the same thing, and you make them work with something like this. We ended up changing the string replace by adding the all parameter at the last position, and we also ended up changing add to preserve the list of emojis that you have before. There is one thing, right? What if you add the same string twice with 2 different definitions of the emoji? You have to decide what you expect from that. And then you write it on the test, and then you go to the code and fix it accordingly, and so on, so far. So that's a very basic example of working with test-driven development to create something, right? Let's make it, let's make sure that it passes, of course. And now let's make it a little bit more complex. Instead of a sequential thing, we want to create a process for the emojifier, right? And we want to create a gen server process for the emojifier because we are so fancy. So we start with an OTP behavior. And so we need to go here, we check the tests, we read the test, the functionality is good, so we need to change it. We need to change this function so that the emojifier is a gen server. And so we changed it to this. Do you see the difference? No? That's intended. There is no difference because the test is explaining the desired functionality. It doesn't matter if you implement it with ETS, with a gen server, with a map, or with whatever else you have there. If the test doesn't require you to have the thing living in a different node or whatever other thing that you want functionally, you're free to change the implementation. it's not always so magical, of course. You will see in a couple of slides that sometimes you need to change the test because you need to change some APIs of your code, but the general structure of your tests generally is preserved, and you can do huge refactoring without touching a line there. So what needs to change? This will be very fast. We have 3 functions here, and each one of them has to interface with the Gen server behavior. I'm not teaching you how Gen servers work, so if you don't know, just trust me. Or go check it yourself. It's on GitHub. So the first one starts the Gen server instead of returning the thing, and so it calls init. If you don't is not a functional requirement that we need. So we have to make a trade-off in our way of applying test-driven development. There are more options. These are 3 that I came up with, and they fit on the slide, so there you go. If you want more options, we can talk later. So the first option here is to just live with the warning, right? The warning is there. It's a warning. Who cares? We move on. We have 100% test coverage. All of our code is generated through tests, so we respect test-driven development. But we have warnings. They start piling up. Then it is confusing. And is that a real warning or an accepted warning? So another option is to implement the callback. Just write the code. Write handle info, boom, boom. Actually copy and paste it from the previous Gen server, and that's it. But yeah, that code that you copy pasted will not be covered by tests, and also it will not be driven by your tests. You will get no warnings. That's good. The third option, which is the one that I generally use, is to test the callback. Even if it's not a functional requirement, you add a dump test to exercise the code, so it's covered by test. And in a way, you are respecting test-driven development because you wrote the test, so it forces you to write the code, right? This is what I will show you. What I usually do is this. I add another function with a very meaningful name, like this is here only to complete the coverage. This is not a real test. And I do what I need to do to exercise the callback period. Like I send whatever message, doesn't matter, right? So what happens? I get the test passing, but another warning, a different one than before, because the function is not implemented. So I go and implement the function in the dumbest way possible, like that, and run the test. No warnings, all the tests pass. Some guilt in my mind, but I can always travel through the future and have the optional callbacks and be very, very happy. So next stage. We had a Gen server. Now we want an actual application, right? The emojifier. We want to share the emojifier with the world and not having people copy and paste the Gen server that I just created. So I will use Reward 3 for that. And when you use Reward 3, you have multiple different frameworks that you can use for testing. I will use Common Test. The other ones follow the same principles. It's not that you have to use common test. It's just it was easy for me. I was tempted to start with rebar config like that, with all the usual things that I put in rebar config, but then I would have to explain all of them to you, and I actually already gave a talk a year ago about them, so this is the rebar config file. That's it. I believe that the project could be run without the rebar config file, but I'm not brave enough, so I have an empty file there, just in case. The other configuration file that I need is the application source. It's a rebar config file in the sense that it is .source, but it's actually an OTP requirement, right? The .app file with a description of the application, blah, blah. But the most important line here is the last one that says that the application is started using the emojifier module. Lately, I've been using another module like emojifier_app, but I already had the slides before. I didn't want to change them, so emojifier it is. And so to run the test, you do rebar3 CT, that stands for common test. And as you can see, of course, we don't have any test. So all the tests pass automatically. But let's add the first one. The tests are written in the test subfolder. They have this naming convention, _suite, all caps, but they also respect the CT suite behavior. The CT suite behavior only forces you to write the all callback with no arguments. That returns the list of tests. I have tons of funny stories about people that didn't want to write the all function because it's repeating the names of the exported functions, and they made magical functions with parse transform, macros, and many, many other things. Find me outside, and I can show you. I actually have some in my computer. Crazy stuff. Anyway, let's do with the regular stuff. We have an exported function app with one argument, and that's our test. So it's in the list that all returns. The test uses equals, because common test works in the same way as I was using before. It uses equals for assertion. That's why I like it for this. Even if it is good for other things, I like this one to show on screen because the test is basically the same one as before. In this test, what I'm checking is that the emojifier app can be started as a regular Erlang app, and it can also be stopped as a regular Erlang app. Of course, I run the test, and I get bombarded with a lot. This is super compressed, right? There are lots of lines there that, in the end, the only one that matters is the one that says undefined emojifier start normal no args, which is basically saying you have to implement the start callback for the application. I create the emojifier module, the behavior is application, and the callback is start with 2 arguments. So I put the 2 arguments there, and what do I do inside this thing? I have to return something that complies with the application protocol so the application can be started. But I know what it is. It's a supervisor module, the main supervisor. So I am tricking. I'm doing a little cheating here and adding the corresponding call to emojifier supervisor. And of course, I created emojifier supervisor. But the part that goes with everything I said before is the init. You see, it's an empty supervisor. The test didn't require any children there, any child. So no child, no children, only the supervisor. Everything else is supervisor boilerplate, the same thing as usual. And so I run the test, and they pass, but there is a warning, just like before. There is a warning because I'm not implementing the stop one callback from the application module. If anybody from the OTP team is listening, that callback should be an optional callback. That one should be an optional callback so that next time I cannot show this on the screen. So what do I need to do? Complete coverage, just like before, but this time we can do it in a different test, just because it's easier, but the same thing. Just run the function, disregard the result, everything else. So I run the thing, and of course, I don't have the stop function implemented, so I go to the application module and implement that callback. So I run the test, all 2 tests passed. Now we have to write the actual tests, the ones that show the functionality that we need from the Emojifier app. And we start, as usual, by copy and pasting. Right? Same test as before, but now it's here. But there are a couple of things that we can improve. We can remove the last part of complete coverage because by the way that we are going to implement it, we don't need it. And remember, that was not a functional requirement, so I can take it away. And another thing that I can do is forget about the first line. Because I can, in common test, there is a way in which I can assume that, in this case, Emojifier app is running already, so I don't need to start it as part of the test. There you go. How do I write the assumption that the Emojifier app is actually running? Oh, no, one step before. That code doesn't work because I removed the variable, right? So Emojifier 0 is gone. There are multiple ways of fixing this. I will show you one that goes against what I said before, just so you see it. Let's say we can have emojifiers, right? And so we can start an emojifier somewhere and use it. Or we can say there will only be one emojifier per node, right? Emojifier app has the functions, and we don't care. There is the emojifier, period. So we remove that thing from all the functions, like this. You see what I did, right? Just remove the parameter that was passed in and out. But the code stayed the same, right? The functional requirements are the same. The only difference is that they don't need the parameter passed in and out each time. And then the assumption. This is how I tell common test that before running Emojify test, you need to start the Emojifier application. And after you're done with the test, you need to stop it. Why this is good? Because if init per test case fails, the test is not even run. And if end per test case fails, the test result for Emojify is not altered. If it's successful, it will be successful. The end per test case failure will be shown in a different way, right? So you can have your test, you have to fix the assumptions. And also because now the Emojify test explains exactly the functionality expected from the server, from the system, without the context. So we run the test, and we are missing functions and stuff like that. So we go ahead and implement. I'm jumping a couple of steps, like the same fast forwarding as before. What I needed to add was a child to the supervisor module. I call it Emojifier GRUK, and with a start link function to start, and Emojifier GRUK is the same gen server as before, but now it has a name, so I have to put a name on it, local Emojifier GRUK, and then gen server call with the name, and gen server cast with the name, and I got rid of the result from add, because I don't need it anymore. Now it can be a pure gen server cast thing. I'm going super fast. I know if you have doubts, I have the slides. The slides are public. I will give you a QR code at the end, but find me around. I can show you. And I also needed the functions on the Emojifier module because the test calls the Emojifier module, not the Emojifier GRUK module. So it's the facade thing. And so it calls Emojify, calls Emojifier that module, and add the same thing. With all of that, the test passed. But yeah, I ran really fast here, and so you would be, the good thing that you can do will be not to trust me. Like, I could have lied to you very much, and so you can say, hey, show me that your code is actually covered by tests, right? That you're not writing this from memory. Okay, let's do that. We can run river3 CT with -- cover, and then we can run river3 cover -- verbose. And that will give us a coverage report. You see the last line, cover index HTML, and you can go there and check which lines are covered and which lines are not. But who cares? It's 100%, right? Okay, that's a lesson. That's a great lesson to learn. If you have 100% coverage in your code, one thing, you may or may not have been respecting test-driven development to the letter. But one thing is certain. If anybody introduces a change to your code and the coverage goes down, it's because of them. There is no doubt. And from then on, there are many, many more. This talk could be days. Because once you start writing your code like that, you end up facing problems like, how do I test side effects? How do I test stuff that happens periodically? How do I test that a certain thing that has to convert multiple values works for all the values, or there is a very, very fringe edge case, etc., etc. There are tools for that. There are techniques for that, but there are also tools for that, like Proper, to run property-based testing, and I heard yesterday about mutation testing and many other things like that, that you will start needing, which is great, and so you will start using them, which is even greater. And if you don't know about them, you can talk to these people and other people. Like Pablo knows a lot about property-based testing and mutation testing. Fred wrote a book about property-based testing, right? So if you have any doubts, that's the guy. And I'm giving you this talk. So I have Chapa. I can talk about it. And jokes aside, this is a very open community. Doing TDD by the book is not easy. It's easy when it's simple, but then it becomes increasingly difficult as your systems grow. Don't stop. Like, go to Slack, Reddit, the Erlang forums, everywhere. Ask for help. The community is very open, very welcoming, and we are there to help you, because it's in our own interest that you do things in the way that we can maintain them later if we end up in your company. And that's it. Thank you very much. The slides are online in that QR and that URL. Oh, I missed one very, very important thing. Thanks, Baxter, my current company, for allowing me to be here and talk to you. If you want to know what we do or how, you can talk to me, to Slava, Mark, and all the others, Piotr, Bartek, and everybody else that works at the company. We do really interesting stuff. So if you want to learn about us, just find us. Now, thank you very much.
Thank you so much, Brujo. Well, unfortunately, we're out of time. We need to prepare for the next presentation here. So thank you again so much. And please ask questions, find them outside.
Post the questions, either find me around or post the questions on Hua and I will reply. Thank you.